Hi, dear friends. Hope you are doing well. Today, we are learning a very important topic of chemistry, and the name of the topic is stoichiometry. The word stoi means element, and geometry means measurements. So in stoichiometry, we do measurements of elements, or we can say we calculate here the mass, the moles of reactants, products. So that's how stoichiometry works. Today's learning objectives, we will see how can we convert mole to mole, then mole to mass, mass to mole, and mass to mass. So let's start with an example. Here we have how to convert mole to mole. Here is an example given. Example is how many moles of nitrogen gas are needed to react with 13.5 moles of hydrogen gas to form ammonia. So we have to see how many moles of nitrogen are needed so that they react with 13.5 moles of hydrogen to form ammonia. So let's see how we can do this. First thing first, we will write a chemical reaction. Let's see, H2 gas plus N2 gas gives NH3. So this is the chemical reaction. Now we will balance it. So balance. So I will write H2 plus N2 gives NH3. So here I will balance it like this. You can do it balancing, but here I'm just showing how can we put it in balanced form. So now the chemical reaction is balanced. Next step is we will write the ratio. Okay, we have to see what is the ratio hydrogen to nitrogen. So here hydrogen to nitrogen gas, the ratio would be, how can we find the ratio? We have to see the coefficients. Here the coefficient of hydrogen is 3, and here the coefficient of nitrogen is 1. So we will write ratio 3:1. So this is ratio of hydrogen to nitrogen. What is next step? Next step is we will write what is given. Given is there are 13 grams of hydrogen. Sorry, 13 moles. So 13.5 moles of hydrogen. So you write it below this. I can erase it. I will make it a little bit left so that you will, beneath hydrogen, you will write 13.5 mole. So now here for nitrogen, we don't know, there is not a single value given for nitrogen. So instead of writing nitrogen, number of moles of nitrogen, I will write X, variable X, and we will try to find out its value later on. So now what is the next step I should do? Let's cross multiply this. Here, I will cross multiply them, and let's see from here. X into 3, that would be 3x. And 1 into 13.5 mole, so that would be 13.5 mole. So now value of X is equal to 13.5 mole divided by 3. So finally I will get, that would be 4.5 moles. So now moles of N2, that means nitrogen gas, is 4.5. So this is the way how can we find out how many moles are there for the nitrogen when 13.5 moles of hydrogen react. So this is one example. Let's move for next step. It is mole to mole conversion. Now I will show you how can we convert a mole to mass. Here is an example given. How many grams of carbon dioxide are formed when 4 moles of propane react with oxygen? So first thing first, what we will do, I will write solution for this. Solution is like that. I will write reaction. A reaction is C3H8. That means propane, plus O2, that means hydrogen, and CO2, that's carbon dioxide. Then this reaction gives water as well. So Now I will balance this. Balance. So next step, after writing the chemical reaction in equation form, then we have to balance it. So I'll write it in the balanced form. H8 plus O2 gives CO2 plus H2O. So I have already balanced it. So I know this 1 times, it would be 5 times, and 3 to 4 times. So now this chemical reaction is in balanced form. This chemical equation is in balanced form. What is the next step? We will take now the ratio. Ratio of those substances we want to compare. Here, carbon dioxide, we have to find how much is formed. And what is given? Given is 4 moles of propane. So I will write here propane, that is ratio for propane. C3H8 is to, or this is the ratio, is to CO3. So here, propane is 1 times, and carbon dioxide, this is dioxide, I have written it. Let me reverse this part. Sorry. It is CO2. I have written it CO3. So now let's see. Propane is 1 times, its coefficient is 1. Carbon dioxide is, its coefficient is 3. So I will write ratio 3. Now what is the next step? Next step is what is given. The propane, the moles of propane are 4 moles. So I will write here 4 moles. So propane is 4 moles. And for carbon dioxide, we don't know how many moles are there. So instead of writing moles, I will write variable X. So now what I need to do, I will cross multiply it just like I did before. So here I will write it. X into 1, that would be X. 3 into 4 moles. 3 into 4, that means 12. So it would be 12 moles. So what is 12 moles? That means X. X means carbon dioxide. I can write moles of CO2. That is X, that means 12 moles. Okay, now I have to find out its mass of carbon dioxide. Before this, I will write molar mass of carbon dioxide. Molar mass of CO2, that is 44 gram. Okay, let's move to next page. Here, I will write now mass of CO2, 12 into 44, and that would be 528 grams. So this is how we can find carbon dioxide, the mass of carbon dioxide in this chemical reaction. Let's move for another part, that is mass to mole. How can we convert mass to mole? Let's see this. How many moles of hydrogen gas are needed to react with 6 grams of nitrogen gas to form ammonia? So let's write the reaction first. Reaction. Reaction is, again, hydrogen. It was the first part we did. Same, but the values are different. And nitrogen gives ammonia. So NH3. The next step is balance it. So I will balance it just like we did in first example. So it gives us NH3, balancing it like this, 3 times, 1 times, 2 times. So balancing. So here, what I will do first, I will try to find out the moles of nitrogen, though the mass of nitrogen is given. So I will write here first, given mass of nitrogen is 6 grams and molar mass of nitrogen is 28 grams per mole. Okay. Now, moles of nitrogen, moles of N2 is equal to given mass by molar mass. And I'll use next paper. Yeah. Given mass, molar mass, well, that would be 6 divided by 28. That would be 0.23 moles of N2. So moles of N2 gas, nitrogen gas, would be 0.23 moles. Okay, now we have moles of nitrogen. Let's write now the ratio of nitrogen to hydrogen to nitrogen. So if we see from the equation, I will write first hydrogen is to nitrogen. So in the equation above, you can see hydrogen is 3 times. So I will write 3 is to, and nitrogen is 1 times. Now I will write moles for nitrogen. For moles for hydrogen, I will write X, and moles for nitrogen we just found above, that is 0.23 moles. So here cross multiply. I can find it from this side. 3 into 0.23 is equivalent to 1 into X, that's X. So when we multiply it, 23 so it would be 69, 0.69. Or I can write here moles of hydrogen, 0.69 moles. So now 0.69 moles are needed to react with 6 grams of nitrogen. 0.69 moles of hydrogen are needed to react with 6 grams of nitrogen. So this question is now done. And now we have final task. That is how many grams of oxygen react with 10 grams of hydrogen to form water. So let's write the chemical reaction first. Reaction. What is the chemical reaction? That is H2 plus O2 gives H2O. So now what we will do? We will balance it first. So here, if I multiply hydrogen on 2, hydrogen to oxygen 2, but oxygen is 1. So if I put here 2, oxygen is 2, but hydrogen is 4, so here 2. Now I think this is balanced. 4 hydrogen, 2 oxygen, and 2 oxygen. Yeah, correct. So now I have balanced this chemical reaction. This is 1 times. It is 1 times so that you understand it. So now this is the balanced chemical reaction. Or we can write it here. 2 times H2 so that it becomes very clear. And 1 times O2 gives 2 times H2O. So this is the balanced chemical reaction. Molar mass of H2, that is 2 grams per mole. Molar mass of O2, that is 32 grams per mole. Molar mass of H2O, that is 2 plus 18 grams per mole. So now let's find moles of hydrogen. I'll write here. Given mass of H2, that is 10 grams. Okay. Molar mass of H2, we have written that 2 grams per mole. So now we will find moles of hydrogen. Moles of hydrogen, that is given mass divided by molar mass. So that is 10 by 2. So it is 5 moles. So moles of H2, 5 moles. Ratio, now we will take ratio of hydrogen to this ratio. H2O oxygen. So H is 2 times. So I will write 2. Oxygen is 1 times. Now how many moles of hydrogen are there? There are 5 moles. So I will write here 5 below hydrogen. And for oxygen, I will write X. So now we will cross multiply just like we did. So 5x into 2. So 2x. 5 ones are 5. So x is equivalent to 5 divided by 2. So x is equivalent to 2.5 moles. So moles of oh, oxygen is equal to 2.5. Finally, mass of O2, that means oxygen, is 2.5 into it is molar mass, that is 32. So it becomes 80 grams. So this is how we can convert moles into moles, moles into mass, or mass into moles. And this way we can solve the questions related to stoichiometry. Hope you enjoyed the topic. Thanks for watching.